All right, boys and girls, today we are doing chapter 2 in your math book. So go ahead and write down, pencil malfunction. Go ahead and write chapter 2. And it's chapter 2, multiply whole numbers. That's the name of our chapter. And hopefully you guys realized after taking this last test for chapter 1 that it's actually really quite helpful to have your notes in front of you in this nice notebook. So chapter 2, multiply whole numbers, and it's lesson 1, which is very easy, is just prime factorization. And I'm always really excited when we do this lesson, well, I should say this whole chapter, because the prime factorization is really fun. It's like taking these numbers and breaking them down into pieces, and I love doing it. So before we even start this lesson, we need to go over some vocabulary that if you don't know, you won't be able to answer these questions. So the first one is the word product. Okay, and we're thinking mathematically here, right? So what is a product? Well, a product is an answer to a multiplication problem. So the answer to a multiplication problem is a product. For example, 4 times 6 equals 24. 24 is the product. Okay, it's my answer. And remember, go ahead and pause me if you need to. Then we need to know, what is a composite number? Because today is going to be all about breaking composite numbers into prime numbers. So a composite number is a whole number, so it can't be a decimal or a fraction. It's a whole number that can be written as a product of prime numbers. Now, when I see an answer like this or a definition like this, I'm like, okay, wait, what does that mean? So that's the real definition, a number that can be written as a product of prime numbers. But basically what it means is that it can be divided by more than one and itself. So let's give an example here. For example, the number, let's say 20, well, we'll take 24. 24 is a composite number because you can divide that by like 2, which would give you 12. You could divide that by 6, which would give you 4. So this is a composite number. It can't just be divided by itself or 1. And we'll get into this more, so if it's super confusing, don't worry, it'll become more clear soon. So if we have product here and we have composite here, well then what we need to have next is a prime number. Okay, now a prime number is a number, so a whole number I should say, that only has 2 factors, which are 1, the number 1, which are, and itself. For example, if I have the number 7, 7 can only be divided by 7 or 1 without getting some kind of remainder. Okay, so that's a prime number. And there aren't that many prime numbers in the world. All right, I'm going to pause for a second and give you guys a second to catch up. All right, so now we'll go ahead and head over to our a bigger desk. We head over to our paper over here, and we're going to go ahead and read this. So you can write every composite number as a product of prime factors. This is called prime factorization of a number. A factor tree is a diagram that shows the prime factorization of a composite number. So this is a prime factor tree, a factor tree. This is a factor tree. What I don't like about the way that this is set up is it's a little too rigid for me. So we're going to go ahead and put notes in our book, in our notebook, that I think will be easier. So I don't have a ton of room here, so I'm going to go ahead and go to the other side so that I have a little space. So we're going to take the number 36. Actually, I'm going to write prime factorization here so that I know what this is. So we're going to take the number 36 and we're going to make a tree. So in a tree, like a pine tree, it's going to go out. Or a Christmas tree, it goes out. Starts little, goes bigger. So I want you to think about two numbers that you can make 36 with. So this times this will equal 36. And you always want to put your smaller number, your least number here, and your greater number here. So when I think of 36, I think of my first thought is 4 and 9. Okay, so we'll just use this as an example. So go ahead and use this too. I could have put 6 and 6. I could have done 3 and 12. I could have done 2 and 18. But right now we're going to do 4 and 9. And I'll tell you that no matter what, at the end, we're going to get the same answers. And I'll prove that to you guys in a second. So now I'm looking for a prime number. So is 4 a prime number, or can it only be divided by 4 and 1, or can it be divided by other things? Okay, and it can be done. We could do 2 times 2. 2 times 2 would equal 4. Now, is 2 a prime number? Yes. So if 2 is a prime number, you're going to go ahead and circle that because it's a prime number. Anything that's prime, we circle so that we're done with it. You can't break 2 into a smaller number, okay, or into smaller factors. Now go to 9. So we want two numbers that can make 9, and you don't want to do 1 and 9 because then you're going to have a 9 over here that you still have to break down. So let's go to the biggest numbers possible, okay, because this is not a prime number. So we'll do 3 and 3. And again, 3s are both prime numbers, so we're going to keep those. So now you look at this, and no matter what order these numbers are in, you're going to write them down here from least to greatest. So I see 2 2s, so I'll write 2, and then you write times 2. So 2 times 2, and then you continue. I see a 3, and I see a 3. So I have 2, 2, 3, 3. This is my prime factorization of 36. Now the guess and check, or excuse me, the check on this is to multiply and see if you get 36. So let's start with the biggest numbers because it's always easier to start bigger. So 3 times 3 is 9, times 2 is 18, times 2 is 36. Okay, so that's a way of prime factorization. But you could also try this way. If we want to make 36, we could also do 3 and 12. So let's try that. Is 3 a prime number already? Yes, so we're going to go ahead and circle 3. But 12 is not a prime number, so let's break that down into two numbers. Again, there's multiple ways we could do it, but let's just do 2 and 6. All right, is 2 a prime number? And the answer is yes. Okay, then we look at 6. How can we break down 6? Well, remember we're putting the smaller number first, the greater number last. So 2 times 3 makes 6. And again, these are all prime numbers. So now to get the prime factorization, we take the smallest numbers again. So it's 2 times 2 times 3 times 3. So this matches up here. Even though we use different numbers to break up our 36 in the beginning, it's still the same prime factorization. Okay, so those are your notes for today. Let's go over, we're going to do some of the problems together, and then the problems that we don't do together, you have a quiz on Canvas that you're going to need to do. So, all right, number 4, we're going to do together. So if you don't think you have enough room to write right here, I would turn my paper this way or use binder paper so I have room to write the 40, the prime factorization. So we're finding the prime factorization of each number. So again, whatever we do, we want to put the least number here on the left side and the greater number over here. And that's only for organization issues. It will help you later when we're working with really big numbers, but if you mixed it up and you put the greater number here and the least number there, it wouldn't be a big deal. All right, so 40, let's do 5 and 8. Well, I know that 5 can only be divided by 5 or 1, so 5 is a prime number. Now, but 8 is not a prime number, so let's break that down. 8 can be 2 and 4. We already said 2 is a prime number, so now let's break down that 4. The 4 is going to be 2 times 2. Can you break these down any further? Nope, that's why we put circles on them. So now we have 3 2s and 1 5. So up here in your answers, you're going to write 2 times 2 times 2 times 5. And this right here is your answer. Okay, now I would expect you guys are going to have a lot of questions about this, so please, please, please come online and ask us your questions. I just realized that this was one of the ones that I put on your quiz, so you got one answer right here, so you guys better get that one right. All right, so let's try number 8. Number 8, we want to prime factor the number 49. So 49, the only thing I can think of for 49 is 7 times 7 makes 49. And there's nothing else that I can do with 7. 7s are already prime factors. So your answer for 49 is your answer for number 8, which is 49, is 7 times 7. Okay? All right, now let's do one of these bottom ones because they do look a little tricky. You have 10 and 12 on your quiz, so we'll do number 11. We're working backwards here. We have the answer of 55, and we're finding the missing number, so our answer is 55. So this problem says 55 equals something times 11. So now I'm going to work backwards. 11 times what equals 55? Well, hey, I know 11 times 5 equals 55. And that's what you'll do on number 12 and on number 10. Okay, so this is what you're doing today. You have some problems on here that are not on your quiz. You can do these, but you need to do your quiz and turn that in. So the ones that are on your quiz are mandatory. These other ones are not mandatory. All right, so when you're done, you're going to take your quiz and you're going to attach your notes to the lesson as well. All right? Let us know if you need help. Bye.